So let's solve this by graphing. Obviously, we can make use of the slope and y-intercept. Note that your slope and y-intercept is written in the form y equals mx plus b, where m is your slope and your b is your y-intercept. So remember that slope m, b, that's your y-intercept. Okay, let's go to the first one first. You have y equals 1/2 x minus 2. What's your slope here? It's equal to 1/2. How about your y-intercept? -2. So this is your y-intercept. This is your slope. With the slope which is equal to 1/2, that means that your rise is equal to 1 and your run is equal to 2. And the y-intercept -2 will give you the coordinates of the y-intercept, which is 0, -2. And in order to use this method, y slope and y-intercept, we first start locating your y-intercept. Your y-intercept is 0, -2. So where is that? 0, -2. It's 2 units below your point of origin. So we count 2 units below. 1, 2. There you go. 0, 0, -2 here. Then we use our rise run to locate another point. Starting from 0, -2, your rise is positive, so we move up 1 unit. How about your run? It's gonna be 2, right? So 1, 2, that's another point, and we can put the coordinates of that point to be 2, -1. And then we connect these 2 points. So connecting these 2 points, you have this. You have that line, the graph of y equals 1/2 x minus 2. Let's go to another line, y equals 2x plus 1. What do you think is the slope here? 2. But we need a denominator. What's the denominator of 2? 1, because we need the run. And the y-intercept is equal to 1. Coordinates of that, 0, 1. So our rise here is equal to 2. Run equals 1. So let's plot this one out. Plot the point 0, 1. Where is 0, 1 in the y-axis? It's 1 unit above the point of origin. So this is 0, 1. Up next, locate another point by doing rise run. 2 is the rise, so that would be 1, 2, run 1, and here's another point with coordinates 1, 3. All right, 1, 3. And the next step, connect these 2 points. All right, so this is your graph. The graph of y equals 2x plus 1. Let me draw this correctly because I think that I've connected the 2 points in not so accurate. So let's see, where will they meet? Where will they meet? See, now if you don't draw your graph accurately, you will not be able to get the solution correctly. All right, so where do they meet? They meet here. And what are the coordinates of that point? It's going to be -2, -2, -3, and that's your solution. Your solution is -2, -3. But let's try to check that. Is our solution correct? To check that, we just plug in. All right, so we plug in. Now let's check our solution -2, -3 by plugging into our first equation. Y equals 1 of x minus 2. What's our y? It's -3. 1/2 your x, plug in -2 minus 2. All right, that's still -3. Negative 1/2 times -2 is -2/2. And what's -2 divided by 2? -1 minus 2. What's -1 minus 2? -3. And yes, we are correct there. But there's one more thing. It must satisfy the second one, 2x plus 1. It must satisfy y equals 2x plus 1. So let's plug in again. Y -3. We have 2. Your x is -3. It's a negative. Oh, I think -2. All right, that's -2 plus 1. Still -3. 2 times -3, -4 plus 1. What's -4 plus 1? All right, so both equations are satisfied, then that means that we've graphed it so accurately, and the solution is really -2, -3. Now, what kind of system is this? It's the independent system because there's only one point of intersection. There's only one solution, and we call this system the independent system. So we can classify this as independent system because it has only one solution. And one way to find out is by graphing. If they only have one point of intersection, then that indicates that there's only one solution, and that means the system is independent.